Okay, guys, today we are going to talk about trigonal trichotomy law of integers, which is P7. In the previous video, we have learned properties of integers, especially the algebraic properties of integers, ranging from P1 closure property all the way to P6, which is distributive property. And today we will talk about trichotomy law of integer. So take a look at this statement. There is a subset n, a set of natural number of the set of integer z, like this. Okay? Where this set n is a set containing 1, 2, 3, and all the way, and so on. This subset of integer z satisfy these three properties. Number one is that 0 is not contained in the set of natural number. That's number one. Number two, if you pick two elements from the set of natural number, a plus b is in the set of natural number, and a times b is in the set of natural number. Okay, pick two elements, and then you can say that we can imply that a plus b belong to the set of natural number and a times b belong to the set of natural number. And the third one, if you pick one of the element from a set of integers, we can say that this x is in the natural number, or it can be 0, or negative number, negative x is a natural number. Meaning is that when you pick x from the set of integer, we can say that x is a set of integer, meaning x is positive, or x is 0, or minus x is a set of natural number, is in a set of natural number, meaning x is less than 0. Okay, x is an integer that is less than 0, or negative integer. These are trigonometry law. Okay, these are conditions satisfying trigonometry law. So take a look at this note. For number two, what does it mean? It's meaning that the set of positive integer is closed under addition and under multiplication. And the third one, when you pick one of the integer, you might have positive integer, or 0, or negative integers. So what is the advantage of trigonometry law? It is advantageous when you're comparing two integers or and proving inequalities involving integers. So in the following definition, we will give the definition of less than or greater than. So if you pick two integers, let's say a and b, we will have the following statement. Number one is that a is greater than b. Number two, a is less than b. So what does it mean by a greater than b? Meaning we have this notation. Okay? A, this arrow to b. What does it mean by this? A greater than b. It means that you multiply both sides by b. Like this. Okay? A minus b is greater than 0. Meaning that a minus b must be an integer. That's number one. So if a greater than b, then we can say that a minus b is contained in a set of integer. Or if you have a minus b containing in a set of integer, this means that a must be greater than b. Alright? On number two, less than. A less than b. What does it mean by this? A less than b. If we have a less than b, we can have b less than a. Okay? So a less than b imply that b greater than a, or b greater than a implies that a less than b. So we will use these two definitions. Okay. So now let's use this definition to prove the following properties. Here, take a look at this one. Theorem 1.1.3, properties of integers. So we let a, b, c, x, y, and z be integer, and we have the following properties. Number one, if a is greater than b, we can add both sides by the same integer c. Okay, that's number one. Number two, if a is greater than b and b is greater than c, we can imply that a must be greater than c. Transitivity. Okay, greater sign has transitivity properties, or transitive property. Number three, if a greater than b and x greater than y. All right. So on the left side of the equation, we add it by a, or we add it by x. On the left side, since x is greater than y, okay, since x is greater than y, and a is greater than b, so we can have a greater than b, and x greater than y, like this. And the fourth one, if you have a greater than b and x greater than 0, if you multiply both sides of this equation by positive number, we're gonna have ax greater than bx. Okay, if a is greater than b and x less than 0, and if you multiply both sides by a negative number, the sign of the direction of inequality will be in the opposite. You multiply by the negative number. Okay, so let's prove the first one. So for this one, we will start with letting a, b, c, x, y, and z be integers. Okay, and we assume that we are going to prove number one. Proof number one. Assume that a is greater than b. Okay, and then we will try to show that a plus c greater than b plus c. Okay, so what does it imply when a greater than b? By definition, here we can have a minus b is in the set of natural number. So we're gonna have a minus b in the set of natural number. Okay, and then what do we have? Since I want to start with a plus c minus b plus c. Okay, I'm gonna show that this one is contained in the set of natural number. So we're gonna have a plus c minus b minus c. Then it turns out to be, so plus c minus c will be cancelled, so it turns out to be a minus b. And a minus b, we know that is in the set of natural number. Okay, this means that a plus c minus b plus c is in the set of natural number. Therefore, a plus c is greater than b plus c. Alright? Number two. How to deal with number two? For number two, if a greater than b and b greater than z, then a greater than z. Okay? So, I will assume that a is greater than b and b greater than z. Okay? Then, what can we do? Then, we're going to have these two statements. So, a minus b. A and b are integer. And if a is greater than b, a minus b will be in the set of integer. Okay? And b greater than z, what happened? B greater than z becomes b minus c is in the set of natural number. Okay? And then, what can we do? We have these two integers. According to Trichotomy Law, let me copy this law. Here. We know that if you select any two natural number, what do we have? We're gonna have closure property, right? So, a and b, if a and b are natural number, a plus b must be a natural number. So, by trichotomy law, trichotomy law, number two, what do we have? A minus b plus b minus c is in natural number. Okay, but what is this one? What is this one? I'm gonna move this like this, and we're gonna have. We want to prove that a is greater than c. So we want to start with a minus c. And what is a minus c exactly? Actually, a minus c is a minus b plus b minus c. As you can see, minus b plus b we cancel. So you're going to have a minus c. So a minus c is in the set of natural number. Okay, so therefore a is greater than c. Alright, the third one. Let's prove the third one. If a is greater than b and x is greater than y, a plus x is greater than b plus y. Alright, so we will assume that a is greater than b and x is greater than y. Okay, then what do we have? We can have a minus b is in the set of natural number, and x minus y is in the set of natural number. Okay, and then what can we do? We have these two integers or two natural number. So a minus b plus x minus y must be natural number, right? Okay, so now we will use trichotomy law again. Okay, the second law here, if a and b are positive integer, a plus b must be positive integer. The second law. So I want to start with a plus x minus b plus y. So I'm gonna try to show that a plus x minus b plus y, which is turns out to be a plus x minus b minus y. Then what do we have? Okay, we're gonna use commutative property. So we're gonna have a minus b plus x minus y. And a minus b is in the set of natural number. X minus y is also in the set of natural number. So the sum of these two positive integer must be in the set of natural number. Alright? Therefore, a plus x is greater than b plus y. That's it. Okay? That's the third one. Number four. Okay? So let I copy this property. Okay? For number four, if we have a greater than b and x greater than 0, then ax greater than bx. Alright, so we're gonna assume that a is greater than b and x greater than 0. Okay, so a greater than b and x greater than 0. So by definition of inequality, so a minus b must be in the set of natural number, and x, which is an integer, and greater than 0, so it must be in the set of natural number. We want to show this one, ax greater than bx. So again, we will use trichotomy law. Okay, we use trichotomy law. So by trichotomy law, the second one, okay, the second law, what do we have? We're gonna have ax minus bx, and we use distributive property, so we're gonna have ab times x, and a minus b is an integer, is a positive integer. X is also a positive integer. So we're gonna have the product of these two positive integers, which satisfy in the second law of trichotomy law. So it turns out to be in the set of natural number. Okay? So therefore ax is greater than bx. Great. And the last one, the fifth one. The fifth one is here. A greater than b and x less than 0. Then ax is less than bx. Okay. So the step is the same. The way to do is almost the same, okay? Okay, give me a second. Proof of number 5. Here. Let's assume that. So we have to assume that a is greater than b and x is less than 0. Okay? So what do we have? So by definition, okay? So we have a greater than b and x less than 0. This means that a is greater than b and minus x is an integer that is greater than 0. And by trichotomy law, by definition of inequality, we're gonna have a minus b is in the set of natural number and minus x is in the set of natural number. Okay, so by trichotomy law, okay, the second one, what do we have? Okay, I want to start with bx minus ax because take a look at, when you take a look at the direction of inequality, we can have ax less than bx. I want to start with bx greater than ax. Okay, and then we're gonna have, what do we have here? Okay, I'm gonna have minus bx plus a times minus x, and then we gonna have minus b times minus x plus a times minus x. Then we gonna have minus b plus a times minus x. Okay, then what do we have next? We gonna have a plus minus b times minus x. Okay, and then a plus minus b becomes a minus b times minus x. As you can see, a minus b is in the set of natural number. Minus x is in the set of natural number. By trichotomy law, the product of these two positive integers is in a set of positive integers. So this means that ax minus ax is in the set of natural number, which implies that bx greater than ax, and ax greater than bx greater than ax is mean that ax less than bx. Okay, got it? And that's what we have. Okay, this is how to use trichotomy law of integers to prove property of inequalities. All right, so in the next video we're gonna prove these properties of inequality, but the difference is the direction of inequality. Okay, they are all less than. Okay, the assumptions start with less than, and we have less than here in the conclusion. All right, and that's it for today.